optimized Genesis sequence.
I'm going to show you something. Welcome in room 7. We're going to show you an app, a little project, a project created by two people that happen to be on this stage. It's MelodyMatrix.rocks. It's an application and a website which is running on the GVM, of course. And I promise I only have a few slides which are AI generated. That's the first one. If you ask ChatGPT how a 14-year-old boy looks like, it's written with a 1 and a 5, apparently. He's a full-stack musician, doing different instruments, making his own music. He's the kind of kid that gets blocked from GTA because he manipulated his score. And so he wants to become a hacker. I try to push him in the direction of an ethical hacker. He's the project manager of MelodyMatrix. That means that he has all the IDs. And he wants to become rich. That's also a little side goal of this project. According to ChatGPT, a 50-year-old Java developer looks like this. Look around. I don't know, for the beard, I think I need some work there. I'm Frank. That's Vic, by the way. I write a lot about Java. I work as a technical writer for Azul. I have some YouTube tutorials about Java, JavaFX. I also write for Fujay, the website for the Friends of OpenJDK. And for me, this project is a learning project. Becoming rich would be nice, but let's learn something. Let's see what we can do with Java, JavaFX, Kotlin. We'll come to that. So that's my goal of this project. That means I'm the minion, I'm doing the work that Vic wants me to do, because he has a lot of ideas. Now, Java for desktop. Can I ask, who of you writes Java code? That's what I expected. Yeah, indeed. Who writes Java for backend services? Yeah, also what I was expecting. And who writes Java, JavaFX for desktop applications? Yeah. Unfortunately, that's also what I was expecting, but actually we should be proud of what we can do with Java for the desktop, for desktop applications. Because without mentioning my topic, I got a complaint about Electron and Slack and needing several gigabytes to run something which was actually designed for the web on a desktop. So we can do better. We can do better than using something which was designed for websites to build desktop applications. And as Java developers, we have the tools to do that. We have JavaFX, which is a full OpenJDK project. So if you go to github.com, by the way, all the links in this presentation, I'll give you a QR code at the end so you can find them all combined. Within OpenJDK, you have the JFX project, meaning JavaFX. It has the same release cycle as OpenJDK, so it's also JavaFX 23 since September. So that means everyone can contribute, everyone can check the sources, can create a ticket if there's a problem. So it's a full open source project. We should be proud of that. It's something you can check the sources, contribute, and see how it works. And yes, we are from Belgium, so we should be proud of the Belgian side of JavaFX. Gluon, a Belgian-based company, is one of the main maintainers of this whole system. Of course, Oracle is involved. Kevin Rushford from Oracle is one of the leads deciding what happens with JavaFX, but Johan Vos of Gluon is the other one. And on Gluon, you can find runtimes for JavaFX applications. Azul, Belsoft, some others have also OpenJDK distributions with JavaFX packaged inside. That's one of the things that changed in JavaFX. At some point, it was taken out of the runtime, but you can still find runtimes which has it combined. If you want to learn more about JavaFX, I invite you to visit javfxcentral.com. It's a website dedicated to JavaFX, what you can build with it, who the people are behind it, what libraries are available to build user interfaces. And what's nice is, of course, this is built with Java, this website, and JavaFX. So it runs on the web, but it is a JavaFX application. It runs on the desktop. Of course, Java runs everywhere. It runs on iOS and soon also as an Android application. And all of these have the same sources. It's just the build that's different. And the sources are on GitHub again, so it's an open source project. And all the data inside this website, the tutorials, the news, the people, the companies, is also an open source project. It's the second GitHub link on that screen. So if you are a JavaFX creator, you have created something and you want to contribute it to this website, please visit javfxcentral.com. Okay, back to MelodyMatrix. How did it start? Vic has a hobby of creating piano movies. Movies like this one. Oh, too fast. Like this one. So it connects to a piano. It gets the input from the piano, and you have this kind of animations. Now, this particular example is created with C Music, created with Unity. Yeah, Unity. So it's actually a gaming engine which is involved here because it's a lot of animations. And he challenged me, can we do the same thing? Can we create some application that can do the same thing, but a bit differently? We can add extra things. And of course we can, because we have MIDI. Who knows MIDI? Yeah, quite some people. Yes. Good. This is the first presentation with music. So I like it. MIDI is a standard. It's a standard. It's an old standard. It's very stable, and it is included in Java. So if you want to connect to a device and get the data that you receive from an instrument, you can already do that with Java. If you go to the OpenJDK project, to the sources of Java, you will find all the code that can connect to a MIDI device and read this data, read the MIDI file and stuff like that. And it's a bit old. I have to admit, this code is old, but because it's old, it also shows that the standard is very stable. Now, when I started working on this little project, I also did a Fougier podcast. So I do this podcast for the Fougier website. And we have Geert Bevin. I don't know if you know him. Again, be proud of Belgium. It's the Belgian guy. It was one of the first Belgian Java champions, together with Stefan, who organizes this conference. He's a music specialist, but he's also the creator of Rive and Build. So Rive is a competitor of Spring, Build is a competitor of Maven and Gradle. But now he lives in the States, works for MOOC, and builds software for instruments. So I talked with him in this podcast about MIDI, and also with Atsushi, that you see here. And Atsushi is the creator of the KT MIDI library, which is a Kotlin library, a multi-platform library that he uses to connect with devices and create several applications. So I found these interesting, and I thought we can do something with that. Now let's look into this MIDI data. What is MIDI data? It's only 3 bytes. You get 3 bytes of data if something happens on the instrument. The first byte is a status, 4 bits, and a channel, because you can hook up to 15 instruments on a MIDI chain. So you could have several pianos or other instruments on the same chain. And then you have 2 bytes of data. And what is inside that data is defined by the status byte. So if you have a node on or off event, status, then you get the node number and the velocity, how hard it's being pressed. Okay? This article there on top has a very nice description about the standard. Now let's see what happens. Of course, because MelodyMatrix is created around these MIDI events, we can show you, because we use JavaFX, we can create all kinds of visual interfaces. So we have a very simple table and one node. So that's the C4, the Do. I'm not a musician, so I have to look at the piano. So if he loses the button, you see we have 2 events. So we got first one was 3 bytes with this value and these two values. And now if he hits the note a bit harder or softer, you will see that the velocity changes. Okay, let's play it. Let's play something. So you see all these MIDI events, they flow in. And it's just data. It's the same things we use with messaging. We want to create an order. So it's the same thing we do with Java in our day job, but instead of a boring create an invoice, it's play me a note or stop playing that note. So all these visualizations, this interface, it took me half an hour to create it. I know it looks a bit very simple, so I should spend a few hours on styling it, but creating something like this in JavaFX is so easy. Now, who has a pet project? Who spent way too much time on it? Who makes it too complicated? Okay, of course. Why not? So I did the same thing. So for the UI, I have JavaFX. I already talked about it. KT-MIDI is the library to communicate with the instrument. Why did I choose KT-MIDI? Because it has some additional features that I like and that I can use in the application. The app code is in Kotlin. Why Kotlin? We will come back to that. And the website, of course, I'm a Java champion. I have to use Java. So I use Spring Boot and Vaadin. And why? Because I know these tools. I can create a website in hours and get it online with the full experience of menus and sign in and the shopping part. I can do that with Spring Boot and Vaadin. So that's what I used. And of course, automate the boring part. I really hate deploying, setting up servers. So I do that very fast in the beginning of a project and then automate it. And that's what I do with GitHub Actions and JDeploy. JDeploy is a tool that packages a JavaFX app, creates an installer, and also takes care of updating it once it's installed. So we have this kind of architecture for GitHub projects. The left one is a public repository with the installers. That's managed by JDeploy. Because we want to sell this, we have a private repository with the application code. We'll see which parts of this move to the open repository. And we have a public repository with the views, because I hope that this project can be some kind of inspiration for others. What can I do with JavaFX that's not a boring business application? And maybe one day we will have contributions from others and see what they can bring to the project. And we have the website which is created with Java, Vaadin, and Spring Boot, as I said, and GitHub Action pushes it on every commit to the server and restarts. No Kubernetes, no complicated stuff. Yes, the website goes offline for 30 seconds when we deploy a new one, but we don't have that many sales yet. None. Spoiler alert, yes. Two things I want to highlight here. If you are looking for an easy solution to deploy a Java application or something else on the cloud, uberspace.de, which is a German hosting provider, for €5 a month you have a VPS and you can install whatever you want on it. Like I use Java runtime and the PostgreSQL database. You can do that with €5 per month. Ideal for a project like this. That shouldn't cost us too much. And another one is, if you hope to sell something, is please don't make the mistake I made with something else, with a book, is sell it yourself and make your accountant crazy. Because every sales is a nightmare because you need to create an invoice. Every country has a different tax system. So look at a merchant of record. If you want to sell a software, if you are a GitHub sponsor, if you use that sponsor link, link it to something like this. They will manage all the invoicing, the tax stuff, and of course they will take a percentage for them, but you don't have any work with that. Polar.sh is the one I'm going to use because it's pretty new and they open source a lot of what they do and they're very responsive. So that's a small tip. Now, why Kotlin? This is me. When my presentation was finished yesterday and I saw this and I needed to add it, because Kotlin has some advantages. Yes, Java has been evolving in the direction of Kotlin, but still it has some things I like. So let's look at it. There are 4 bullets I want to highlight. I will come back to them. It is actually on the JVM that it's running, so that's the thing I love and use a lot. JVM and Java are very stable, so I have this stability inside my project, but you can still mix Java and Kotlin, which is really great. And you can write cleaner code, according to some, according to me, but not everyone agrees. And that's an important thing. The last sentence is Tom Cole's. We organized the BJUG together. He organized mostly iBit. If you start a new project and you want to learn something, then only introduce one new thing. Don't make it too complicated for yourself. In my case, it was Kotlin. So Kotlin is the thing in MelodyMatrix that I'm learning. So I'm not making use of all the functionality that is available in Kotlin, like multi-platform, like Compose, but I'm still learning there, and I'm using the language now. Now, it runs on the JVM. That's a very important topic, this evolution of the Java runtime. Who's still on Java 8? Wow, less and less hands every conference. That's a good thing. Yes, we are on Java 23 since September. So that means that every 6 months we have a new version of Java which brings new features, which has improvements and where we can make use of as a developer. No, you don't need to bump your production system to every new version, but please keep an eye on these evolutions that if the next long-term support version becomes available 25 September next year, you're prepared, that you know how you can improve your code and that you can take advantage of all these things that happened with all these releases. Or in our case, we needed something which was in Java 21, so we definitely are following that thing. And the thing we needed was virtual threads. But there are a lot of different evolutions within the language, like switch expressions, pattern matching for switch, text blocks. For me, these are the important ones because they make your code more readable. And readable code is the most important thing. Mariet van Dijk shared the message about you read more code than you write code. You go back to your code to find the bug. You read code from your colleague. You read code you have written yourself 6 months ago. And making your code readable, that you understand what's happening, is very important. And that's what these Java evolutions bring. And beside all the evolutions, you have, of course, memory and speed improvements. Running a Java 8 application on Java 21 will bring you a lot of improvements without needing to change anything in your runtime. Let me highlight the podcast again. Every 6 months, I have a podcast about the evolutions in the new version of Java. Please tune in or read one of the many blogs on Fujay about this topic and many others. JVM and Java are stable. People are surprised that you can run a 13-year-old self-contained jar on the latest JVM. And that's true. You can still run an old Java on an old jar on the latest thing. And why? Because Java is boring. And it should be boring. Everything you do should be boring. You don't need surprises in your work. Keep that for after work. Your work should be stable. And that's one of the main things that Java brings us. And you can mix Java and Kotlin. And that's really a nice thing in this project. Of course, I didn't write everything myself for this application, for the things you have seen now. I use a lot of libraries. And these libraries are mostly written in Java. But I can combine them in a Kotlin code, in a Kotlin project. So I'm using KT-MIDI, we already had it. Atlanta FX is a theme for Java FX to style your application and has some extra components. Charts, I'm going to see a demo by that. FXGL is actually a game engine written in Java FX. And it's the one that is used for the effect on the piano, for these particles. So we are using, again, a game engine also in Java FX. It's written by Almas Baim from the UK. To be honest, he has written the piano that you've just seen in JavaFX. I asked him, do you think we can make that? And half an hour later, he said, yes, you can, because here is the code. So that's how fast things can go. And then you have Java CV, which is a wrapper around FFmpeg, so we can export our screens in JavaFX to a video file. So soon he will be able to upload, instead of the C Music movies, our movies that we created with his JavaFX application. He's still not fully happy with the animations, so we have some work to do. I have a very tough project manager. Okay, let's see what we can do. So another way to look at music is with charts. We all are used to dashboards. So let's play something and see what happens with charts. So this is a library created by Gerrit Grunwald, one of my heroes within the JavaFX world, which now happens to be a colleague at Azul. So he creates a charts library. And what you see here is that just like we would have logging stuff coming in or the sales of the month or whatever, we can also link this to real incoming data. So that's what we see now. Which notes are being played, or which octave. So let's hit one button a lot. One. A lot. So you will see somewhere in the high things, the yellow thing is going up there. Isn't this nice? Fun? Does it have any use case? I don't think so, but it's fun. And that's the goal of our application. Build something which is fun, that you can look at music in another way than we are used to. And as I said, this is a demo case of what you can do with JavaFX. That's my goal of this project. I can just let him play if you want. Okay, cleaner code. This is how you typically construct the layout in JavaFX. You start with a border pane. A border pane is the typical Outlook configuration of a screen with a top bar, left, right, middle, top, bottom. So you can put in a border pane any content you want. So in this case, in the left column, we will have a vertical box with 3 buttons. This is clean code. This is readable, no problem at all. What I don't really like is the VBox, which returns on the left. So you construct the VBox, and then you have to use the VBox again to set properties of it. In Kotlin, you have the apply method. And the apply method allows you to nest stuff in each other. And you can immediately apply properties to something you're initializing. Is this more readable? Some say yes, some say no. I like this approach. And to maybe convince you, I've written a blog post about it with a video where I have a more extended example of this, where it's shown with more examples and a full project, where the same interface is created with both Java and Kotlin combined with JavaFX. Now, one important thing I wanted to talk about is virtual threads. This is the last ChatGPT image. Virtual threads combined with music, because thanks to virtual threads, we were able to solve something in the application which was at first looked very complicated. Now, what are virtual threads? It's something which was introduced in OpenJDK 19 as a preview feature within Project Loom. And I want to mention it here because this again shows the power of the 6-month release cycle. So in Java 19, they said, yeah, we have a good idea. Let's create virtual threads, lightweight threads, but it's not ready. We want your opinion. What do you think about it? So they introduced it as a preview feature. You could not use it standard. You had to enable it in your IDE, and you have to start your Java runtime with an extra flag, enable preview features. And that's how they get feedback. So how the Java contributors, the people who really write the Java codes and the runtime, how they get feedback. And they had a second preview feature, a second version in 20. And for 21, they said, yeah, this is it. This is what we're going to use. And they introduced it as a finalized feature. So it's now available since 21 as part of the Java code. So virtual threads are lightweight threads, as they call them. And they are managed by the GVN runtime. And they have no one-to-one mapping with the OS threads. That's, if you ask ChatGPT, describe virtual threads, these are the bullet points. But let's show it. So imagine you have a system with 4 threads, which can do tasks for you. And you start a first task. then it will be assigned to the operating system thread and it will start handling it. And that task remains coupled to that thread, OS thread, until it's finished. Even if it has to wait for an API call, even if it has to wait for a database to return a set of records. So it stays there. So if you have 4 tasks, 4 operating system threads, no problem. If you have a 5th task, then you're blocked. Yeah, that was a very short block. It's blocked. So this 5th task has to wait until one of the other ones is completely finished. Now, virtual threads is something completely different. That's something which is just, yeah, it's fun. You can just launch as much virtual tasks as you want, and the GVM will pick them and will assign them to the operating system threads. And something happens, the task 2 is waiting for the database. Oh, no problem, to the to-do list. And it picks another one. So you have this constant flow of tasks towards the operating system threads and back until they get finished. So you can launch a lot of tasks without thinking about how much memory they use, because it's a very small Java piece of code. And like this, so they will be handled and sent to the operating system threads. But you have to use them with care. It's a tool to improve concurrency. So switching between tasks. So switching between all these blocks of things that have to be done if they are blocking. So if a task can get blocked at some point, then it's ideal to make it into a virtual task. So also if you're waiting for a file, for instance, you have to read a file. So it's not for long-running tasks. If you have a task which gets a lot of data, has to calculate something on it, generate a report, store it on a system. Yeah, maybe the store is a blocking operation. But if you have a long-running task, don't create it as a virtual thread. It's not the ideal use case. Okay. So a little example, creating a traditional thread versus a virtual thread is very simple. So that's why you have to be careful. It's just a little change in your code, but you should not use it all the time. Okay. Now, we have an ideal use case for virtual threads in MelodyMatrix. We have this MIDI recording. So a MIDI recording is actually just a start time and then a bunch of data lines being through 3 bytes and again a timestamp. When did this MIDI event happen? So we have the start of a recording, then we have a note on, we have a note off, yeah? Then we have another note on, we have another note on. So we have a lot of nodes and timestamps. So it looks like this. It's a very simple JSON file. So you see the 3 bytes of data, you see the timestamp. Now, can this be handled with virtual threads? I was first looking at a solution. I have to load all this data and then calculate what should happen at which time and then have some engine processing this data. No, I don't need that because I can just go through all the lines, and on line 6 you see I create a data player with the data and a timestamp, and then I start it as a virtual thread. And what is this data player doing? Waiting. That's the only thing it does. It waits until the timestamp that it has to send the data. And then it sends the data, and the task is finished, and it's gone. So what we can do now is launch all these MIDI events. They don't take a lot of memory, and then just let the GVM handle it and play them at the right time. Now, of course, we have to prove that this is working. So what I can show you is, let's create a recording, a short one. So we are now capturing all the events of the piano. So you see we have 100 events. Okay, thank you. Finish the recording. And I have here for you a thread counter. So let's just start this. That means that if I hit the play button, it will go through this list of MIDI events, create a virtual thread so that they are ready to be played back. Yeah, you're hearing myself, which is a really bad idea. Actually, it should have been the piano playing this back. Never mind. Let's make a longer recording. Let's see if this also goes for a lot of events. So now we had 100 events. Go wild. Let's create a bunch of events. About 1,000 would be enough, I think, for a short demo, which takes a bit longer also, a bit longer to record. We have a recording of 4,000 events, but we'll not wait that long. Okay, thank you. So again, virtual thread counter. So here we have the recording. So you see that's one of the features we have in the application. So you can create recordings, you can save them to a JSON file, and you can play them back. Now you're hearing the piano. So what's actually happening is all these virtual threads are happening, and they are sending this MIDI data through this little cable here to the piano, and you hear the piano now playing back all these events. Which is the best player, the musician or the virtual threads? I don't hear any real difference. Maybe you have to do this scientifically, but I don't hear any difference. So the virtual threads are really capable of handling 1,000 events and many more. We have blog posts from people testing out 100,000 virtual tasks being scheduled to be fired at some point, because they are just little Java objects waiting to happen. And that's something we can do with the virtual threads, which is a really nice approach, which allows you to schedule work within your application in a way that we were not used to. Okay. We're going a bit fast, I think, but we'll see. Now, people who know me maybe know me as the Java on Raspberry Pi guy. I do a lot of experiments the last years with Java on Raspberry Pi and how you can interact between Java and electronic components. I even wrote a book about it. So I have a bunch of toys at my desk, like LED strips and stuff like that. So yeah, is there something we can do with that and combine it with the application we have here? And yeah, of course, otherwise I wouldn't be here telling you about this. So I have a LED strip, and I have this little small device. And again, there we have the power of software. This is a little device that expects a serial link, a serial communication. It's something like the people of my age will know from printers at some point. It's a very simple way of sending data to another device. And on the pins on the other side, you can connect LED strips, 8 in this case, and you just need to send a byte array of data to this device, and it will send it, forward it to the LED strip. Because a LED strip is a pretty complicated device to control, it requires a very strict timing, which is hard from an operating system, but a chip like this can do that. So again, I have this very simple JavaFX UI. You see a lot of blocks which are just rectangles. For every node there is a rectangle. We have a color chooser, we have duration settings, so you have the 8 channels at the bottom to check which of these should be doing something. And again, we can do this with very simple code. We are in Java, we have a lot of power in there and availability of functions we can do to create something. So what we need in this case is a byte array, which is the length of the number of nodes multiplied by 3, because for every LED we need an RGB value, so red, green, and blue. And that's what we send to the LED strip. Okay, so again, let's show this. Yep. So this is the UI. We can control some of the width of the effect and how long it takes. So it follows the piano keys again. Huh? Now if I enable this serial communication, yes, the demo gods are here, then you see that we have it on the LED strip. And it's following just the same things that we are doing here or happening on that LED strip. Can make it a bit psychedelic. And isn't this fun that we can do all this kind of stuff with Java, with the tools we're used to, that we can make a fun project and explore whatever is possible. So I find JavaFX a really great tool. I think I mentioned that already a few times. Because it allows me to build this kind of stuff very easily. So I mentioned before, like the video recording. Yeah. There is a bug in the software. I should not open this twice. So the demo gods are not really here. Like this simple button here. What this does, it's actually now capturing the whole screen here and sending it to an MP4 file. This was the kind of code I didn't have experience with, but we have some systems nowadays that can help us search and generate some example code. So this kind of files, I don't know where did I select to save it. Okay, test files. So this little recording I don't find it. Never mind. The MP4 file is here. So we can just create a recording because all these libraries are there that wrapper around FFmpeg that we can use to combine it into our codes. Okay. Now, as I mentioned at the beginning, I also want this project to be some kind of example project of what you can do with JavaFX. So the views project is something which is a public repository. Now, it's a Git submodule, as I call it, that I use within the application, but it is also a standalone application. So if I launch this from my IDE, so you see within my main project, I have the main application code, I have the viewers code, and within the viewer codes, I have a full GitHub and Maven. You can choose if you load a Gradle and a Maven project, so you can use which one you load. And you can launch this. And you have the same views as we have seen before, but you don't need all the things around it. You don't need a piano, you don't need an instrument. You can just launch some random playback here, so you don't hear anything, but you see what's happening. So if you're interested in seeing how these viewers work, there's some very nice ways to bind the controls, for instance, to what is happening within the visualization. All this code is public and you can view it in the viewers project. So it's a GitHub repository. Check it out. And if you want to contribute, it's also there. So all the viewers are here. The charts one. By the way, I had a bug here, and thanks to the community, being Garrett Grunwald, this was solved yesterday. So that's also one of those amazing things in Java. You can reach out to people. You can reach out to the creators of libraries. Even the creators of Java itself, they are here. You talk to them probably already in the conference. So the test project, the viewers project, is a project which is open to you. So if you think some of these views are interesting to build something else, or you have a very nice idea, this is also a way that you can look at music, please let us know or contribute to this project. Okay, that was the test app. Now, do you want to contribute? Of course you can. We just saw the viewers project. You can buy a license. We can make him rich. that's one way you can help us build this project. Or you can call us and tell us your ID. It had to be in the presentation. Okay. We're a bit fast, but anyhow, we can have questions. This is the link to the page to my blog. The first post is a list of all the links we have in this presentation. So if you want to listen to the podcast, Fuji podcast, if you want to look into the sources of the project, if you want to know more about what we do, and MelodyMatrix, of course, everything is on this blog post as a list with links. Okay, thank you. And are there any questions? Yes?
I was wondering what the polling rate is how many MIDI events you can process per second.
I actually have no idea because I didn't hit limit. It's not a polling system. It's implemented within that KT MIDI library. It just receives it. I think it's more a push system. The limit that you can reach, I can show you in the test launcher, is actually the visualization. There could be a problem. So if I have this piano view, so if I now start some random playback, and I go here very fast, I don't think I can find a piano player, not even him, who can play that fast. So we didn't hit the limit yet. It's probably somewhere defined in the standard, in the MIDI standard, but I have no idea. No. Stop. I don't want to hypnotize you by all these flying particles. Are there any other questions? Yeah.
Is it possible to combine string and then especially the injection components?
Yeah.
JavaFX?
Yeah, dependency injection in JavaFX. I had just a discussion with that about that topic here at Devoxx. There is no built-in way in JavaFX for dependency injection. There are some people who combine it with Spring dependency injection. What I really like and are looking forward is Quartz. Quartz dependency injection. There is a project, Quartz JavaFX called, I think. We just talked about it 2 hours ago. We will look into it. It's not finished yet, but it's a way indeed to have dependency injection in JavaFX. It's a problem I have here. Like for instance, the class which is responsible for communicating with the MIDI device, I have to construct it in my application and forward it the whole time to every component that needs it. It works, of course, but dependency injection would be a much nicer way to do that. So I will either do it with Quartz, not Quartz, Quarkus, sorry. I've been here too long. With Quarkus, I will take a look at it, and maybe you will see it here as an example. So that's definitely something to look at. But Spring dependency injection, there are some people have done that with JavaFX already, yes. Okay.
A question. Is it possible to run in the headless mode? Because I imagine situation I have a piano in the living room and Raspberry Pi connected to it and generating
forwarding the data. Yeah, forwarding the data. It would be possible. I have done a lot of... So the question is, can you run it headless? Not yet. Maybe you can contribute something for that. Yeah, a good idea to contribute. Yeah, it would be an idea to have some box connected to the instrument and then have another PC to collect it.
The video for the YouTube, because in the YouTube there's a lot of videos
Yeah.
that visualize the piano. However, possibly I do not want to have a piano that's connected to
Yeah,
the screen
yeah.
and to the real PC, just Raspberry Pi. So as the Raspberry Pi guy, it's a good idea for the introduction.
Yeah, I should mention that I'm the Raspberry Pi guy. Yeah, there's definitely a way to run this headless. Actually, you could build something very small in Java to capture the MIDI events and put them on a message bus and get them somewhere else. That would be the kind of... Yes, but that would be the kind of way, the step too far away for a pet project. But definitely, yeah, that's why we will do it. Yeah, that's why we will do it, yes. It is possible, yes. Okay, yeah?
Yeah, I saw that you have like an option to record, and I'm not sure, but I think you are using your own like data format to store it.
Yeah.
Or is it
Um, yeah, very good question indeed. So let me run the other application again. So for now, I'm just saving. So the question is, can I load other formats or export to other formats? For now, it's just JSON. Even with an audio recording, there is a byte array in there with a long MP3 file. So the MP3 file itself is inside the recording. So you can indeed open recordings and have them play back. So that's one we made before. We have on the wish list to go from MIDI to our format or to our application, because like musicians like Vic, they also use MuseScore to write compositions. They allow you to export it in several formats, which one of them is MIDI. And as we already have the MIDI specification implemented in Java, it should be possible to read that as a file and convert it. So yes, it's an option which is on our wish list. So, and converting it back to other formats, if they're open, should be pretty straightforward. Everything is just a Java record, every data line. So converting it to other formats is what's Java good at. So we should be able to do that indeed. Stop. Okay, thank you. One more question or we're finished? Thank you, that's it.
All systems are nominal. Initialize Genesis sequence.